Alright, good day everyone. So welcome back to my YouTube channel, and this is Kasaligan Vlogs. Today we will be talking about probability, and this is mathematics in the modern world. So probability. So probability is a field of mathematics that deals with chance. So we have here an experiment is an activity in which the results cannot be predicted with certainty. Another definition is each repetition of an experiment is called a trial. And an outcome is the result of an experiment. And we have here an event is any collection of outcomes, and a simple event is an event with one only possible outcome. An event can be one outcome or more than one outcome. For example, if a die is rolled and an ace shows, this result called an outcome, since it is a result of a single trial. An event with an outcome is called a simple event. The event of getting an odd number when a die is rolled is called compound event, since it consists of three outcomes or three simple events. In general, a compound event consists of two or more outcomes or simple events. So those are the definitions about probability. So let's have sample space. The sample space for a given experiment is a set S that contains all possible outcomes of an experiment. So sample spaces for various probability experiments are shown here. So example of this experiment are the following. Toss one coin. So the sample space could be head or tail. The roll of a die, that is 1, 2, 3, 4, 5, and 6. Answer a true-false question, so therefore the sample space should be true or false. In tossing two coins, we have here, it could be the sample space that is head, head, tail, tail, head, tail, or tail, head. So those are the examples of the sample spaces. So we have here example number 1. Find the sample space for rolling two dice. Solution, we have here, since each die can land in 6 different ways and two dice are rolled, the sample space can be presented by rectangular array. The sample space is the list of pairs of numbers in this chart. So we have here, this is die 1 and die 2. So for sample space of rolling two dice, so 1 could be paired with 1, right? So we have here, the next is 1 could be paired with 2. So therefore, these are the sample spaces. So we have here 6 and 6. So the total sample spaces here is 36. So 6 by 6. So this is an example of a sample space when rolling two dice. So because we could pair 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Or we can have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Depending on an experiment or the result of an experiment, that is what we call as an outcome. So next we have here example number 2. Finding sample space for drawing one card from an ordinary deck of cards. Of course, an ordinary deck of cards, we have 52 cards. We have here the club, the spade, heart, and diamond. Club or flower. So we have here solution. Since there are 4 suits, okay, there are 4 suits of the deck of cards, the heart, clubs, and diamonds, spades, hearts, club, diamonds, and spades, and 13 cards for each suit, ace through king. So there are 52 outcomes in the sample spaces like this. From ace to king, so we have here 13 cards. Every suit has 13 cards. From heart, there are 13. From ace to king, from diamond, ace to king, 13. And ace for spade, which is ace to king. And for the club or flower, we have ace to king. So there are 52 outcomes in the sample space. So we have here, this is 13 and 13, 13 and 13. So this is an example of a sample space. Next, we have here a fair dice rolled and unbiased coin, rather. This is unbiased coin is tossed. Okay, let's insert here. Coin is tossed. Draw a table to show the possible outcomes. So this is the possible outcomes. So we have here the coin, which are the possible outcome is head or tail, and paired with the dice with 1, 2, 3, 4, 5, and 6. So there are 12 possibilities. The table shows there are 12 possible outcomes. So this is an example of a sample space. Next is the tree diagram. A tree diagram is a device consisting of line segments emanating from a starting point and also from the outcome point. It is used to determine all possible outcomes of probability experiment. So we have here example 1. So use a tree diagram to show all the possible outcomes when two unbiased coins are tossed. So using a tree diagram to show all the possible outcomes when two unbiased coins are tossed. Solution we have here. The diagram shows that there are four possible outcomes. So example of this tree diagram, we have here the first coin is head and tail, and it could be this head could be paired with head or tail. As well as this one, the tail could be paired with head or tail. So therefore, there are four possible outcomes. We have here head head, head tail, tail head, and tail tail. So there are four possible outcomes when you toss when two unbiased coins are tossed. Okay. So example number 2. In example number 2, in example number 2, we have in a drawer there are some white socks and some black socks. Team takes out one sock and then a second. Draw a tree diagram to show the possible outcomes. So there are four possible outcomes, of which two will produce two socks of the same color. So for example, first our team takes black sock, so he could pair it with black or white. And the first could take white, and it could be paired with black or white. So therefore, there are four possible outcomes, which is black black, black white, white black, and white white. Okay, so try this at home. A family special at the neighborhood restaurant offers dinner for four for $39.99. There are three appetizers available, four entries, and three desserts from which to choose. The special includes one of each. Represent the possible dinner combination with a tree diagram. Okay, so try this one at home. Next, let's proceed with the topic. There are three basic interpretations of probability. So first is classical probability. The second one is empirical or relative frequency probability. And the third one is subjective probability. So the first one is classical probability. When I talk about classical probability, it uses sample spaces to determine the numerical probability that an event will happen. You do not actually have to perform the experiment to determine the probability. Classical probability assumes that all outcomes in the sample space are equally likely to occur. So here's the formula for classical probability. The probability of any event E is the number of outcomes E over the total number of outcomes in the sample space. This probability is denoted by the number of outcomes E and the number of total sample space. So therefore, the formula finding the classical probability is event over the sample space. This is called classical probability and it uses the sample space S. Okay, so let's have probabilities can be expressed as fractions, decimals, or where appropriate percentages. Again, it can be fractions, decimals, or percentages, but mostly we could have fractions. So let's have the rounding rule for probabilities. Probabilities should be expressed as reduced fractions or rounded to 2 or 3 decimal places. When the probability of an event is an extremely small decimal, it is permissible to round the decimal to the first non-zero digit after the point. For example, this one. So 0 point, so if we're going to look at, so we have 0.000587. We could be rounded off to the 3 decimal places, which is 0.0006. Okay, this is the rounding rule for probabilities. So let's have example. From a probability of getting a black 10 when drawing a card from a deck. So we have here, so we are going to find the probability of getting a black 10 when drawing a card from a deck. If we could still remember that there are 4 suits, which is heart, diamond, club, and spade. So there are in the deck of a card, so there are 2 black suits. Okay, first is the the spade. Okay. Okay, the spade. And the second one is the flower or T. Okay, the club. So these are getting a black. So this is the spade and this is the club. So we need to find the probability of getting black 10. So therefore, there are 2 black 10s here in drawing a card from a deck. So therefore, probability of black 10 is equal to, again, the probability is event over the sample space, which is 2 over 52. That is, could be reduced, or we should have to reduce it into the lowest term, which is 1 over 26. So this is the probability of getting black 10. Okay. Example number 2. If a family has 3 children, find the probability that 2 of the 3 children are girls. So we have here, let us have the sample spaces first. Our sample space, okay, let's have the sample space. So we have here, first we could have boy, boy, and boy. We could have boy, boy, and girl, since 3 children, and we need to get 2 of the 3 children are girls. So next is boy, girl, boy. Next is girl, boy, boy. We could have girl, 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 and we have girl, girl, boy, and girl, boy, girl, and we have boy, girl, and girl. So probability of 2 girls. So we have here the event over the sample space. Our sample space is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 sample spaces, and we need to get 2 of the 3 of the children are girls. So you have to pick 2 girls here, 1 and 2 and 3. So this is not included, this is not included, this is not included, and this is not included as an event. So therefore, 3 over 8. So the probability of that 2 of the 3 children are girls is 3 over 8. Okay, let's have example number 3. Okay. A card is drawn from ordinary deck. Find this probability of getting a jack. Of course, and let us have A. So if getting a jack, so we could find, okay, jack. So how many jacks in a deck of cards? So there are four jacks with four suits. Okay, so since no restriction after the suit, so therefore the probability of jack is 4 over 52. Again, they're in a deck of cards which is 52, the standard deck. So we have here four jacks are found there in the standard deck of cards. So next we have letter B. So getting six of clubs. A six and a club. So six, that is a club. So therefore, six of clubs, so we could have only one six of clubs. So therefore, probability of six of club, okay, in a deck of cards, there is only one, which is the event over 52. So therefore, six of club is 1 over 52. Next, letter C, getting a 3 or a diamond. So next is getting 3 or a diamond. So therefore, there are three spade. Okay, the three are could be spade, uh, club, heart, and diamond. These are the suits for the three. Okay, and there the question is 13 or diamond. So there are 13 diamond. So 13 diamonds. So probability. So diamond, that one of the cards of the three has a suit of diamonds, so we have to eject this one because it will be repeated here in the 13 diamond from ace to king. So therefore, how many events do we have? So 1, 2, and 3 plus 13 diamonds because we ejected here or neglected diamond here because it will be twice, it will be counted as twice. So therefore, the probability of 3 or diamond is equal to, we have 16 over 52 is equal to 4 over 13. So that's it for club. Again, let's have to repeat here in 3, there are four suits: the spade, the club, heart, and diamond. So therefore, in 3 alone, so we have 4 events, or the sample spaces could be. But in diamond, there are 13 diamonds from ace to king. Since the 13 diamonds includes the 3 here, so we have to eject one of the diamond here in 3 because these 13 diamonds includes the 3 diamonds. So let us count is as 1 and it cannot be repeated. So 1, 2, 3 plus 13, we have 16 over 52. That's equal to 4 over 13. Next is getting 3 or 6. Okay, getting 3 or 6. So in this case, so let's have the solution here. 6. So there are 4 threes and 4 6 in a deck of cards. So therefore, we could have probability of 3 or 6 is equal to, we have to add this event, so 8 over 52, that is equal to 2 over 13. Again, getting 3. How many 3 do we have? There are 4 threes. And there are 4 6. So therefore, 8 over 52, that is 2 over 13. Okay. Next, we have here, try this at home. If 2 dice are rolled one time, find the probability of getting these results. A sum of 9, a sum of 7 or 11, doubles, a sum less than 9, and a sum greater than or equal to 10. Try this one at home. Okay, let's proceed with four basic probability rules. The first one is probability. Rule number one. The probability of any event E is a number, either fraction or decimal, between and including 0 and 1. So it's denoted by the probability of an event is between 0 and 1. So included here 0 and 1. So again, it is between 0 and 1. There's no negative and there's no probability higher than 1 and lesser than 0. It always between and including 0 and 1. Okay, it should be close interval between 0 and 1. Probability rule number two, if an event cannot occur, event contains no membership in a sample space, it is the probability is 0, or shall we say impossible probability. Example, when a single die is rolled, find the probability of getting a 6. In the die, the sample space is 1, 2, 3, 4, 5, and 6. 9 is not included in the sample space, so therefore probability of getting 9 is 0 over 6 because not included, so therefore 0, and that is what we call as impossible probability. So because it's stated that event contains no membership in the sample space and the probability is 0, or shall we say impossible probability that we could get a 9 out of the sample spaces and a single die is rolled. Probability rule number 3, if an event is certain, the probability is 1. Example, when a single die is rolled, what is the probability of getting a number less than 7? So a single die is rolled, so therefore 1, 2, 3, 4, 5, and 6. These are less than 7. So therefore, the sample space is 6. So the probability of less than 7, the event is how many event that is less than 6? We have 6 and the sample space is 6. So therefore, we have 1. This is what we call as a certain probability. Okay? So rule number 4. Probability rule number 4. The sum of probabilities of all outcomes in the sample space is 1. So, for example, in the rule of fair die, each outcome in the sample space has a probability of 1/6. Hence, the sum of probabilities of an outcomes is as shown here. So, if we're going to add 1/6 plus 1/6, because each year, according to classical probability, they are equally likely to have the same probability. So the probability if each number is 1/6, so therefore when you're going to add this one, the total is always 1. Okay, so there are four basic probability rules. So let's proceed with empirical probability. So the difference between classical and empirical probability is that classical probability assumes that a certain outcomes are equally likely, such as the outcomes when a die is rolled. Okay, while empirical probabilities relies on the actual experience to determine the likelihood of an outcomes. In empirical probability, one might actually roll a given die 600 times, observe the various frequency, and use these frequencies to determine the probability of an outcome. Again, classical is equally likely and probability relies on the actual experience or the frequencies. Okay, so that's all about empirical probability. So formula for empirical probability is that given a frequency distribution, the probability of an event being in a given class is probability of an event is the frequency for the class over the total frequency in the distribution. The probability is called empirical probability and is based on observation. Okay, so we have example number 1 is a sample of 50 people. 21 had a type O blood, 22 had type A blood, and 5 had type B blood, and 2 had type AB blood. Set up for frequency distribution and find the following probabilities. So let's have first the type of blood and the frequency. For type A, we have 22. For type B, we have type B is 5. AB is 2. And we have O is 21. So the total frequency is 50. Okay, the first question is find the probability that a person has a type blood O. If we're going to check based on the frequency, probability of O is equal to 21 frequency over the sample space, which is 50. So this is the probability that a person has a type O blood. Next is a person has a type A or type B blood. So type A and type B blood. So we're going to combine here. So probability of type A or B blood is equal to 22 over 50 plus 2 over 50. 5 over 50 rather, because B is 5. So therefore we have 27 over 50. So that's the probability that a person has type A or type B blood. Letter C, we have here neither type A nor type O blood. So we have here to extract A here in this part, A and O. So we have to extract A or O. So therefore the probability of neither A nor O is equal to. So therefore we have 5 over 50 plus we have here not A, not O. So therefore 5 over 50 and 2 over 50. So therefore we have here 7 over 50. So this is the probability that a person has neither type A nor blood type O blood. Next is the person does not have a type AB blood. So probability of this one, not AB, since the probability is equal to the total probability is 1, so we could have 1 minus probability of AB. Okay, complementary. So 1 minus the probability of AB. What is AB? We have 2 over 50 that is equal to 48 over 50. So 1 minus 2 is equal to this one is 24 over 25. Or we could have this one, we are just going to add 22 plus 5 plus 21 that is equal to 48 over 50 that is equal to 24 over 25. So that's example number 1. Let's proceed with example number 2. Hospital records indicated that the knee replacement patients stayed in the hospital for the number of days shown in the distribution. So the number of days stayed, we have 3, 4, 5, 6, 7, and the frequency is 15, 32, 56, 19, 5, and is equal to the total of 127. The first is find the probabilities that a patient stayed exactly 5. So let's have A. So probability of exactly 5. So since that is frequency over the sample spaces, so exactly 5 we have the probability is 56. That is the frequency over 127. That's the answer. 56 over 127. The next question, letter B, is a patient stayed less than 6 days. So less than 6 days. So therefore, we're going to add the probabilities here, adding the frequency also here over the sample space, which is 127. So probability of we have here patient less than 6 days is equal to, we are going to add 15 over 127 plus 32 over 127 equal plus here 15 over 127. If we're going to add it one, that is 103 over 127. So this is the probability that a patient stayed less than 6 days. Next, we have a patient stayed at most 4 days. So when we talk about at most 4 days, so they mean to say that is the maximum. So the maximum of 4 days, it could be 4 or 3. So the patient, letter C, the probability of at most 4 days is equal to 15 over 127 plus 32 over 127. Okay, at most 15 on 20, 32 over 127. That is equal to 47 over 127. And that is at most 4. Next is a patient. Okay, stayed less than 5, at least 5 days. So we need to say we have the minimum of 5. So therefore 5 to 7. So the probability of at least 5 is equal to 56 over 127 plus 19 over 127 plus 5 over 127. So if we're going to add this one, we have 80 over 127. So we are going to add the frequency here from here because at least 5 days. So 56 plus 19 plus 5 over the total sample space, which is 127. That is equal to 80 over 127. So next we have here subjective probability. The third one is subjective. The third type of probability is called subjective probability. Subjective probability uses a probability valued based on educated guess or estimate, employing opinions and inexact information that is based on our opinion. In subjective probability, a person or group makes an educated guess at the chance that event will occur. This guess is based on the person's experience and evaluation of solution. For example, a sports writer may say that there is 70% probability that Pirates will win the pennant next year. And a physician might say that on the basis of diagnosis, there is 30% of the chance that the patient will need an operation. And seismologists might say there is at 80% of probability that an earthquake will occur in a certain area. These are only a few examples of how subjective probability is used in everyday life. All these three types of probability, classical, empirical, and subjective, are used to solve a variety of problems in business, engineering, and other fields. So therefore, we have done with the three. We have classical, empirical, and subjective probability. So try this at home. A shopping mall has set of a promotion as follows. When an any mall purchase 50 or more, the customer gets a spin the wheel shown here. If a number 1 comes up, the customer wins $10. If the number 2 comes up, the customer wins $5. If the number 3 or 4 comes up, the customer wins a discount coupon. Find the probabilities of A, B, C. Okay, so like this. And try this number 2. The following information shows the amount of debts who graduated from college and core. So we have your person graduates, some debt. Find the probability of this problem. So thank you so much for listening, and I hope everyone you enjoyed the moment and you learned something from the probability introduction. And please do not forget to subscribe the channel and share it to everyone who wants to use this video. Thank you and God bless everyone.